Hello and welcome to today's project demonstration. In this video, I will be showing you how we can create a Bluetooth controlled car using ESP32 microcontroller specially. So as we all know that you all guys have this robotics kit, which is your DIY robotics kit, into which you will have different components. But specifically today, we are going to build Bluetooth controlled car, which is a simple yet one exciting project that combines wireless control, robotics, and embedded programming. So, specifically in this video, you are going to see the coding part, that how one can operate it, and after giving command, you can control your car. So into this kit you have different components, but using the least or the lesser component we can build the Bluetooth car. So the most exciting part about this particular car is that you are going to require only and only few components. Your this baseboard, chassis kit, motor, wheel, few JST connectors or cables, and these screws and nuts. As we already demonstrated into a dedicated video that how one can install Arduino IDE in their laptop or computer devices. So first thing is you need to have Arduino IDE into your device installed and in running mode. So this is the prerequisite for this particular Bluetooth control card. So in order to do coding part, you will be required to have this platform into your device. So if you haven't checked it yet, go and check out our video how to install Arduino IDE into your device. Once you successfully download and install this Arduino IDE software into your device, then you will be able to do the coding part of this Bluetooth control car into the Arduino IDE. So as we all know that what this board is, you have this robotics base board into which you will find one microcontroller which is specifically ESP32. So here we have this powerful and versatile microcontroller that features built-in Wi-Fi and Bluetooth capabilities. Now into this project we will be leveraging its Bluetooth functionality specifically because it has built-in Bluetooth and Wi-Fi capacity. That is why we are going to leverage this Bluetooth functionality to control our car remotely via a smartphone or other Bluetooth enabled device. Into this, we are going to use the ports from which we will connect our motors. We are using 4 motors into this, and the ESP microcontroller's built-in Bluetooth feature is going to be required to remotely control your car. So in here you will see that for motor you have 4 options. Here motor 1 port into which you will find the internal connection is already given. So this is the pin diagram of our robotics baseboard into which the motor is connected with 4 and 2 number pin. Motor 2 has 15 and 13 number of pin. Motor 3 12 and 27, and motor 4 33 and 18. So into this particular we are going to use these 4 ports which are dedicated for motors. So into this we are directly using the Bluetooth feature of this microcontroller. So the only other thing which will be required is the connection to motors, and also yes, a USB cable using which we are going to upload our coding from laptop or computer to this microcontroller. So how to build this robot is, first thing you need to assemble your Bluetooth car. So Bluetooth car can be assembled using following steps, into which you will attach the chassis. Then after, onto that chassis you will mount your robotics baseboard. So after that, attaching that baseboard, what you will do is that you will add the motors, and then after you will be seeing that your hardware connection is done, but we will see this later. First, we will see that how the coding part works. So as soon as you open your Arduino IDE, a screen like this will be there onto your desktop. So here you have this void setup and void loop. So this is the screen once you open Arduino IDE. In here you have different tools or buttons using which you can perform different tasks. So first of all we are going to use our ESP microcontroller. So here the microcontroller which we are using into our Bluetooth control car is ESP32. So in here right now in my device I already have this ESP board. So if into your system, if there is no option of ESP32 board, then first you will be required to add it additionally or select it from preferences. But right now, as you can see, once you once you click onto this is the space from where you can select the microcontroller and onto which port your device is connected. So here once you click here you will have a screen like this from which you can toggle between different boards and select your port. But right now I haven't connected the USB port to my microcontroller, that's why I'm not seeing that. But once you connect your USB port with this microcontroller, then you will be able to see that. But first we are going to see that what kind of steps we need to follow and different tools. So here this is the tool using which you can perform this step of adding microcontroller. Then after you have this option to verify your code. Once you are done with coding, you need to verify it whether the coding or the programming has any errors or it has any problem in it. Problem in sense you have written something wrong which is not acceptable or which cannot be run. So here this system will automatically compile. So the term here is the compile, which is going to check whether there is any mistake or is there any problem into your coding. So it will check your coding or your programming thoroughly and then give suggestion whether it is good to go or is there any mistakes. So if your coding is perfect, then it will give you sign, and if there is any mistakes in your programming, then it will have its errors into the box which is going to be appear into this bottom part. Then after you'll need to upload that coding into your microcontroller using this button. But once you start uploading, it will again compile or it will check your coding and then it will upload to the board. Then after you, if you need to start debug, if there is any error, then you can use this. Then after you have this file option. If you want a new sketch, then you can click onto here and your new sketch will be appear something like this. Then after you have another option into this is to open any file, open recent file. For example, you are working with 2 3 different codings and you need to open the recent files. Then again you need to open a specific sketchbook. Then you have different examples over here depending onto the performance or depending onto the work you require, you can choose any example. So here you will have, as you can see over here, for ESP, for example, we have this ESP module. So for ESP you have this different options to perform the coding for. So if you want to check any coding, then it will give you example and here you will have whole code written over here. So it will give you the coding with it like this. So this is the example coding using which you can perform the particular testing or you can say the options. Then after, if you want to close, you want to save, as the different preferences. As I already mentioned you, that in here you need to add a specific board's manager URL in order to add a different board which is not available in here. So you will add that board's managers directory from different URL and you will paste it here, then you will click OK. So that particular board's manager will be added into this Arduino IDE. Then you can access that particular microcontroller or board later. Then after, if you want to perform any edit related task, any sketch related task, you need to upload, you need to verify this type of things. Then after, you will have these tools using which you can experiment different things. If you want to check boards, that how many available boards you have, Arduino ESP32, ESP boards, this Arduino ABR boards, the Arduino series, this type of boards. Onto which port it is connected, you can select it from here. So these are the tools or specifications which you will have into your Arduino IDE. So this is the basic introduction. Now we are going to see this Bluetooth control cars code, which is I have already written it over here. So this is the coding for Arduino for ESP32 Wave module and Bluetooth control car. So in here, as you can see, we have used the two components, which is your microcontroller, which is already there into your robotics baseboard, and one motor, and different one component is motor. So motors particularly are in four quantity: a front right, front left, back right, back left. So we have four motors and four wheels. So the two component, the first is microcontroller and the other one is BO motor. So these motors are commonly used in robotics for the high torque and low speed operation with rotational speed of 200 rpm, which is revolutions per minute. Now they provide excellent control for our car's movement, and double shaft design also gives us more flexibility, allowing us to drive multiple components simultaneously if we need. But in here, the coding part is important, and you need to understand different things which we have written over here and why we have written this like that. So here into this, you will see that first is hashtag include this particular term. So it will include your Bluetooth serial library. So here we are using the Bluetooth feature of microcontroller. That's why it is required to add that library. After that, we are initializing the Bluetooth serial, and here we are using this as the particular method to add the Bluetooth to our this part. So here this serial bit is an object which is created to handle the Bluetooth communication on this ESP32. Then after, we need to first define the pins onto which pin we have connected different motors. So as you can see over here into our pin diagram, we have the dedicated four ports which are there for four motors. So here motor 1, motor 2, see we have this circular motion, or you can say the clockwise motion, into which first is the motor 1 over here, then motor 2, motor 3 and motor 4. So we have this type of connection. So for that you need to connect your hardware part dedicatedly, something like this. So once you add the motors like this, then you will be able to see that your connection is specifically like this. So first we will see that how this goes. So here we will going to define the motors pins. So first is the motor which is onto the front left. That front left is here. This is the front left motors connecting ports. So 4 and 2. We are using this as motors front left side. So here you will connect your JST connectors onto this pin number 4 and 2, because we are giving signal to motor to rotate. That is why we have used this two particular these two pins to give that signal. Then after for front right, we have used the motor number 2's pins, which is 15 and 13, which is over here. 15 and 13. Then we need to define again the motor which is going to be there onto the backward side, the two wheels or rear wheels. So here rear wheels for motor 3 and motor 4. So this is going to be your back right and this is back left. So here back right and back left 12 27 and 33 18. So this is how we can specify the pins. So back left is 12 and 27 and back right is 33 and 18. So this is how we have added our motors. And then now next thing is to consist PWM channel. So here PWM channel for analog like signal, because these are the motors. That is why we are going to require analog signal. Now here we are using character command because we are going to give command as motor needs to go backward, forward, left or right. So that is why we are using this command as a variable, and that variable is going to stored as character. So here we have used this function. After that is integer speed 200. So we have specified the speed is equals to 200 over here, and this is going to be added into the integer function as this is the integer. So this is the predefined functions which needed to add before void setup. Now into void setup, we are going to declare that that particular pin is going to perform as which type of function. So here we are going to declare that how that pin is going to work, as input or as output device. So here we have different types of devices. Input device is going to collect the data initially from their surrounding mediums, and the output device particularly are going to give output as some form of action or the other way. But here we are using motors which are going to perform to give action. Whatever signal we are going to get needs to be done into the motion. So first thing is we are going to get the data directly from Bluetooth, and after that as the given command motor needs to rotate. That is why the motors are going to perform output devices function, or generally they are actuators, or motors are known as actuators. So actuators mostly work as output device, whereas sensors mainly work as input device. So here the pin mode is going to be specified. So here pin mode means that particular pin is going to operate as which mode, as output or input. So here PIN is going to be in small and M in capital. So this is going to be one mandatory thing for which we are using M as capital. So once you use M as capital, then we have used this particular formation to give your motor its name, because we have different we need to give different signals to different motors. That is why we have used front left, front right, back left, back right, and each terminal has two pins. That is why pin 1 and pin 2. So here as you can see that in our coding we have specified this. Now we are going to again making it as output device. That is why we need to declare it for each and every pin. So here we are declaring FL1, which is the first left one output, first left front left 2 as output, front right again as output, front right 2 again as output. Similar goes for back left, back right, 1 and 2 pin. Here we are using this baud rate as 11520. So here this is the serial begin, which is going to begin the serial communication onto this particular speed. Then after we are going to give the name to our Bluetooth, that this serial BT, which is your Bluetooth serial, is going to appear as this particular name. So whatever name you want to give, you can add it into double inverted sign. So here we have used the name as Robotics, and then after if you want to print anything further, then you can write this particular sentence to see that yes, your Bluetooth connection has successfully established, or else you can also skip this sentence, but this is mandatory. So serial bt dot begin is going to give your Bluetooth of ESP a name. So your ESP32's Bluetooth is going to appear as this name onto your mobile or other Bluetooth device. So this is basically name. So this is the void setup function into which we add pin mode or pin names, which are going to be there as same from starting to ending of your coding or your workflow. So these are the things which are going to be constant throughout the process. That is why we have added into void setup, because we don't want it to repeat over and over again, because these are going to be as constant. That is why into void setup we add something which is there as constant. Now into the void loop we add the motions or some related actions which are going to be there over and over again. So we need to add the particular process that which particular thing should be operate how. So here this is the output device. So that output device do what? So it needs to turn. So it needs to give a specific command for that. So into this void loop we are using that if serial bt is available, meaning if there is any command available, then what it should do. So particular command should particularly give a specific action. So here we are using if option. So here into the void loop we will see that how this particular is going to behave. So this serial bt dot available checks if there is any data received via Bluetooth. So once you pair with Bluetooth device, then it needs to check continuously that if there is any data available. So it is going to check for that. Then after is command. So here we have this command is equals to serial bt dot read. So it is going to read the incoming command. So whatever command is there, it is going to read first that which type of command is received. So it reads the incoming data and stores it in the variable command. So this is the variable command into which the received data will be stored. Then after a serial.println command. Now it's time to print that particular command onto your serial monitor. So here is your serial monitor. Using this, you can see your serial monitor. Right now, we haven't connected it yet. That's why it is seeing like this. So whatever data we are receiving is going to be printed onto the serial monitor using this particular function. So this is serial dot print. So to print onto serial monitor we use this function, and this is ln means in new line. So here we are using semicolons after this each and every command in order to complete that particular thing. Now after this we need to switch the commands. We need to check whether it is command is for forward for forward rotation, backward, left or right. So here we are using this switch option. So the switch option here is that which command is going to be received. So there are different possibilities, because the particular operation or that particular operator of the car can press any button anytime. If the operator wants the car to go into forward direction, then it will press a specific button. If operator wants its car to go into backward direction, then it will press a specific button. So for each and every action we need to have a specific case. So here right now we are adding 5 different cases, which is forward means to make your car move into forward direction, to make your car go in backward direction, which is another case. The third case is your car needs to go into left direction, whereas your car needs to turn in right direction. And when your car is not working at all or it is stopped. So here are 5 different cases, but there can be many as per your choice, but these are the mandatory 5 particular, you can say, the use cases. So here switch command, and into this we are adding case as F, which is for forward, and that is specified by move forward. So move forward is one function, then brake, then another one, which is case B. So here we have B for backward, so move backward. Then after left, which is denoted by capital L, which is for move left. Then after is move right for case R, and case S means stop motors. So these are different case, and we have used this switch function for this. Now for left, we need to make each and every motor signal into different mode in order to make your car move left direction. So for that, we are going to use this analog right function, because the speed of the motor can vary. So here we have this analog right. So using this analog right, this function makes the car move into the left direction. This analog right sends a PWM signal to motor to move into the left direction. So here this particular is for front left to speed up. This is the motor's second pin. Same, the front left motor's second pin at 0. So here this is the combination which can be used in order to make your car to move into left direction. So one pin high, one pin low. The front rides first pin high and the second pin is low. Similar for back left and back right. So high, low, high, low, high, low and high, low. This logic is going to make your motor move left side. Then after we have similar case as right. So in order to make your car turn right or move right side, you need to just make the opposite of this. So here we have given higher and here lower. So this just switch those and make it slower and higher. So this is the logic to make your car move into the right direction. In order to make your car go backward, you need to give this type of signal to each pin, which is the front left one is 0, front left second pin is higher or speed. Speed here is 200. Then after is front right as higher, or 200 and front right second pin as 0. So again, this is the logic for backward motion. And if you want your car to move into the forward direction, then use this: speed 0, 0 speed, then 0 speed, speed 0. So this is the logic behind the forward motion. But if you want to stop your car, then you need to add all the motors pin at lower signal. So here we have added front left 1, front left 2, and all the other pins on 0. This is how you can add coding. Once you have added the coding, now it's time to connect your ESP32 board, or you can say the hardware, with the laptop or computer device in order to upload this particular coding. Once the coding for Bluetooth car is done in your laptop, something like this, now you need to upload this coding into the microcontroller or into this robot car in order to use it and to control it using the Bluetooth application. So for this particular part, what different things you are going to require is this first USB cable, which is like this. So this is the USB cable which is going to be used to upload the code from laptop device to this particular microcontroller. So this particular end of the USB is going to be connected here onto this microcontroller, and this particular is going to connect over here into the laptop. So here the laptop connection will be done from this part side, and this side is going to insert it into microcontroller's board here. This is the DC adapter which we are going to use to power this device in order to make it run. So this is the adapter which is used to power up the car. Then after, you are going to require one Bluetooth application for RC control car, using which you can control the robotic car or Bluetooth control car using the different commands available onto this application. So this type of application is there. You just need to go onto your favorite search engine and search for Bluetooth RC control car. So you will find this APK file from where you can download and install it into your phone. After that, you need to upload this. After now connecting this USB cable successfully with laptop or computer, now it's time to upload the code into this RC car. So here this end is connected with ESP32 board and this end is connected with laptop. Now once you connect this, you can successfully see that your COM port is now visible. So first you need to click on to here and select for the boards. Now you need to search for ESP32 board if you are connecting it for the first time, but I am connecting it for second or third time. That's why the connection is successfully made automatically, as you can see here. But how to search for board is, you have the list as you can see here, and from this list you need to search for ESP32 Dev module, because we have that Dev module. So once you find that board, click on to this, then you will have this check mark over here because we are using right now this board. Then after which port, onto which port it is connected is depended upon the system you are using. So into my system currently that USB is connected onto COM9 port. So here the tick mark is onto this. So I will just select this and click on to OK. So yes, successfully connection is made between the board and laptop. Now you need to first see the coding, that the coding is done properly or not. So I'm going to verify my code. So click on to this verify button and the verify process is started. So it is compiling sketch, or it is gathering the details that if your code has any type of errors or mistakes or not. So it will search thoroughly of your code and give you the result. So here compiling process is almost done. It will take a few seconds only. And also you can see that here you have this written that ESP32 module has connected onto COM9 port. So yes, it is almost done and compiling is done. You have this message of done compiling. Now your code does not have any errors. So now it's ready to upload. So your code is good for uploading onto microcontroller. So when you click upload, as I mentioned earlier, it will automatically go through compiling process and then it will upload into microcontroller. So first it will compile again your code and then it will upload it. So it has now already, yes, done compiling, and it is uploading your code into microcontroller. So this is visible that yes, your code is uploading onto the board. So here, done uploading. You have done the uploading process as well. Now open the application. So I'm using this Bluetooth RC control car. Clicking onto it. Once you click onto this particular application, it will open up something like this. So it will ask you to give permission to connect it with mobile's Bluetooth device. So I'm going to click allow and checking that if it is connected. Yes, so now I will just open the Bluetooth application using which we are going to control the particular car. So open and then click onto this setting button, click onto this connect to car, and your device is already paired with this particular Bluetooth of ESP, which is named as Robotics. As we already mentioned that Robotics will name as Robotics will be appeared onto mobile device. So go to the paired devices option and you will have as Robotics. Once you click onto that, this particular ball will turn off from, right? So now start. But as soon as I look as click F, click, it will be in forward stage. Once in back motion, it will be as B. So as soon as I click here, it will be as B. For forward motion, it is as right R, left for L, and this is how car works. Into the backward direction, into the forward direction, right if you want to turn right,